For ellipses. This is what we did on Monday, and so this won't be the first video that goes up regarding this week's videos, but it is one that I'm going to go ahead and put up there because they were harder questions, and so I didn't get to go over all of these with some of y'all, so please watch so that you can see. So first off, guys, this one, like we said in class, this was a mistake. This should say 24 and 3. No, it's a little hard to see. Change it to a 24. So a 26-inch string is attached to two nails located on a coordinate plane at 0, 3 and at 24, 3. So I'm going to have to come a little bit off the paper here. 20, 21, 22, 23. Right? No, 20, 21, 22, 23, 24. So somewhere around here. So this is asking me to find the equation for an ellipse. So they went in and told me what the shape was, and so like I covered when we went over this in class, I'm gonna need these values. I need A, I need B, and I need the center. Okay, and so center should be easy to find. This is just in between here, and really I didn't see any problems with this when we went over it in class. So the center's at 12, 3. Okay, so the thing I don't know is that what these points actually are. I don't know if they're vertices, I don't know if they're focuses, I don't know what they are. So we're gonna have to use a little common sense. So if I have a string that's 26 inches long, well, that's not much bigger than the 24, but it is gonna hang, something like that, okay? And when I pull it tight, okay, and I follow along, okay, so pretend this is a string. If I follow along, and I pull this tight, well then this is the furthest I can get, and really this, if I keep pulling that string, it'll give me a shape that kind of looks like this. So what I start to see is that this points that I have here is not the vertices, but it's actually the focus, so it has to deal with the C. Now I know from the center to a focus, since I already established this as a focus, I know that value is called C. And, oops, it doesn't really look like a C. That distance I have here is 12 units, okay? Now, what I don't know is, I don't know the A value, I don't know the B value, okay? And so, here, what I can see, though, is, remember, this whole thing's 26 inches, and when I pull it up here, that means half of it is over here, is this 13, half of it's over here, it's another 13. And from the focus to this vertex, that's what I call side A. So that's what I have right here. Now, the B value is what I don't know. This is what I'm going to find. So I can find it using this relationship. Oops, B is what I'm looking for. Okay, where B squared is equal to 25, which means it's equal to B is equal to 5. So now I know all the information I need to make my equation. So again, this is x minus h squared, y minus k squared, where the x is the major direction, so that's where my a goes, and b goes over here. So it's x minus 12, y minus 3, a is 13 squared, which is 169, and my b value is 5 squared, which is 25. Okay, and so this is my final equation here. I'm sorry that this camera is moving so much. I don't know why. So, to move forward, guys, fingers are too big. Okay, this big problem here, this one was a little bit harder. So this is one I didn't get to go over with everybody, so please pay attention here. This is telling me that a rover is going around one of Jupiter's moons, okay, and I know this is a little hard to write on, but it says that 253 miles, the highest it gets is 253 miles, and the lowest the thing gets is 53 miles. So if the center of the moon is, if the radius of the moon 6423 miles. And assuming that the center of the moon is located at 0.00, which is also the focus, center of the moon is the focus. Okay, then first thing they're asking is what is the length of the major axis. So I know it's a little hard to see here, guys, but what I'm saying here is right here, this distance, okay, this distance right here is not as high as it is down here. So they're saying over here, this is 53 miles. Over here, this is 253 miles. Okay, so what I'm going to see here is that this is actually like an elliptical shape. Okay, very similar to, so it's very, very close to a circle, but it's not quite. Okay, it is an ellipse. And I know that, I'm going to go ahead and, the center, the radius, so from here to there is 6423, which means over here is also 6423. Okay, so the major axis is all of this right here, if I add it all up together. So we're here when it's asking for the major axis, 53 plus 253 plus 6423 plus 6423 is the length of the major axis. Now, I don't have that number off the top of my head, so I'm going to go ahead and put this in the calculator. It equals 13,152. Okay, so now I'm asking, next part, determine the coordinates that represent the center of the orbit. Not the center of the moon, guys. Center of the moon's at 0, 0. But remember, this is the orbit going all the way around. So, what I see here, guys, I know that this whole thing is 13,152. Okay, the center of the orbit then is going to be half of that. So 13,152 divided by 2 is 6576 and 6576. Okay, so guys, if I know that from here to there 6576 and the center of the moon's here, the 6423, well then, first off, I know that I'm a little bit lower down here because that's just, since it's bigger down here, like the center of this orbit is more down here. So what I want to find is this distance right here. So I'm going to subtract 6576 from 6423. And when I do that, it equals 153. So if this was 0, 0, this is moving down. So in the x direction, I haven't moved anywhere, but in the y direction, I moved down 153. So that should be my my distance there. Okay. So moving forward, okay, we're not done with this question just yet. It's asking me to find the length of the minor axis. Okay, and so guys, remember that the major axis is A, from the center all the way to the edge of the ellipse, which I already know, I found it out, was 6576. Now, I also know the center to the center of the orbit. Give me the center of the circle, excuse me, of the moon to the center of the orbit, and this is, I could consider as my focus. So from the center to the focus, which I call C, is 153. Okay, so my B value, guys, I'm going to find it using this relationship. Okay, so, I mean, with something like this, these numbers are so big and just so weird, you're going to have a calculator, so I'm going to go ahead and just use NSolve for this. Where my B squared, I'm going to call X squared. And I see that it equals 6574, which makes sense, guys. This B value should be less than the A value, which it is slightly, but but it is still smaller. So 6574. Okay. So, last thing is to determine the standard form. So here, guys, x minus h squared, y minus k squared. And since this is moving in the y direction, again, you won't have to be like this on the test. They will let you know where things are at. This one's bigger, this one's smaller. Okay, so A is the major direction, B is the minor. So this becomes x minus h. Remember, we found the coordinate over here. This is h and k. So x minus 0 squared over b squared, which is 6574 squared. I mean, this number just can be so big. Don't even bother with it. Just say it's that squared. Plus y minus k, so y plus 153 over 6576 squared equals 1. And actually, I didn't answer this question quite all the way. The b value is 6574, but the minor axis is 2 times that. So remember, this was alone was 6574. So the whole major axis should be 6574 times 2. So sorry, I didn't answer that all the way through. So the minor axis is 13,148. Okay, so guys, go through this problem a few times. It is a difficult one. This is really kind of what you'll see on the free response, so please go over it.